Hello and welcome back. So far, we have understood the connectivity between the machine learning and statistics. And let us try to understand how to analyze the error or how to understand whether the model is working good or not. We have got metrics. For regression problem, there will be different metrics, and for classification problem, there will be different metrics. So here, let us try to understand one after the other. Here, let us try to understand the metrics for regression problem one after the other. The predicted value is called as y cap, the actual value is called as y. So the error is the difference between the predicted value and the actual value. Suppose that the actual salary is 80,000, the model is predicting 70,000, the error is going to be 50,000. If the salary is 80,000 and model is predicting 90,000, the error is going to be minus 10,000. So that is called as residual. Okay. So squared error is the square of the error, right? We generally try to take the squared error and residual sum of squared errors, because if you take the errors, right? Previously I said if you have 10 records and first record is giving 10,000 as error, second record is giving minus 10,000 as error, third record is again giving 10,000 as error, fourth record is giving minus 10,000 as error. Like that, if 10 records give you consecutively 10,000 minus 10,000, if you sum up all that, it looks like zero error, and it looks like the model is working good, right? The predicted value should be almost equal to the actual value, right? Even though the predicted value is oscillating back and forth, in that model, in that previous example, we have seen that the total error is zero, right? So to avoid that cancellation effect, we call it as cancellation effect. To avoid that cancellation effect, we square the error and sum it, and we call it as residual sum of squares. There is another way of calculating error, which is actually called as total sum of squares, where you take mean of the actual y value and try to subtract it from the y. That is called as total sum of squares. This total sum of squares is used in R squares code. Let us try to look at the error, squared error and residual error for the salary data we have used in our simple linear regression algorithm. So here I have taken the salary data's experience and passed it to the model, to the predict method, and I predicted the values. The outcome is going to be a series object, and then I set dot values to extract the numpy array from the series object. And then I actually created a new column called as predicted sal, where the numpy array is the column values. So if you look at the head, right, along with the experience, lines of code and salary, we have got predicted salary, right? Here the actual salary is 85,000 and the model is predicting 459. The actual salary is 25,000, the model is predicting 23,000 odd. So the predicted values are almost close to the actual value, but with a simple number or single number, if you want to understand the error, you can use residual sum of squares. Square this error and sum it all, and you get a number that actually shows you the total error on the model. So we are trying to basically assess the magnitude of the error here. So that's where you need to take the square and sum, right? If you don't square and sum, right, the magnitude may go down because of the negative numbers and positive numbers getting cancelled. Okay, so this is residuals, and then I calculated this is the predicted value, and then I calculated residual or error. What is the error? The salary minus predicted value. Here the salary is a series object and predicted value is another series object. We can actually directly do a minus operation between two series objects and create a new column in the data frame. So we did that. So if you don't have data frames and series objects, right, we might have to write lots of code to actually create this, right? And then the squared error, on a series object residuals, I applied *2. That means it's a square of all the values present in the squared in the residuals column, and then I created a squared error column. If you look at the data frame now, We have got predicted value, residual, and squared error. If you sum up all these squared errors, that's called as residual sum of squares. And we have understood total sum of squares also here. Okay, so in the next section, let us try to understand what is R square score and what is adjusted R square score. Thank you.